All right, hey guys, today we are going to be learning about fractional exponents and how they work. So you already did a couple problems where you learned some things about fractional exponents. So on your calculator, in the activity number 1, you actually had to type this in, 9 to the 1/2. If you type that in on your calculator, you end up with 3. If you typed in 16 to the 1/2, you ended up with 4. If you would type in 25 to the 1/2, you ended up with 5. So a lot of you probably kind of figured out like, oh, that's just the same as taking the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Okay, but what if your exponent doesn't look like that? Maybe what if you ended up with like 125 to the 2/3? Okay, where it looks a little bit different. It's not to the 1/2 power. Okay, that's what we're going to learn how to do today. All right, so here's what I'm going to kind of explain to you. So if I am looking at this problem right here, I know 9 to the 1/2 power is 3. Now here's a way to actually think about this. So if you're looking at a fractional exponent, this bottom number is basically how many repeated factors of that number I am taking. So again, repeated factors. So if I look at 9, that's the same as saying 3 times 3. Do you see how I had 2 factors that were the same? That's where this comes from. And then here's what that one part actually can mean. That means I'm just going to take one of those repeated factors, which gave me the answer of 3. Okay, if I come over to 16 to the 1/2, again, I need 2 repeated factors that when I multiply, it gets 16. Well, here's my 2 repeated factors. 4 times 4, that's 16. And the top number tells me how many of those repeated factors I need. I only need one of them. So I'll take that one of them, and I end up with 4. Now, think about that reasoning. What if I would have given you 16 to the 2/2? Again, still a fraction. Okay, so think I need 2 repeated factors. Well, that would be 4 times 4. And I need to take both of them, which is 4 times 4, which would actually just give me 16. Okay, so if I was kind of thinking along those same lines, let's think about 8. Okay, this one, I need 3 repeated factors. So basically, what times what times what is 8? Okay, so that's 2 times 2 times 2. It's basically taking the cube root of it, right? Now, I just want one of those factors, so if I just take one of them, my answer to this is actually 2. Now, go ahead and on your calculator, I want you to try to type that in and just confirm that that's right. So I'm going to type in 8 to the, a lot of your calculators might look like this, to the 1/3 power. Okay, and when you type into the 1/3 power, most of your calculators have a fraction button. I'm going to show you how you do that if you weren't sure. You can actually type in a 1, and then most calculators have this button that looks like this, A, B, C, kind of like that with like a fraction. That's how you type in a fraction. So if you type in 8 to the power of 1/3, you should end up with 2. Okay, that's most calculators. Now, some calculators, you might have to type it like this. You might have to type 8 to the, it might say like x to the y power, like this. And then you would need to type in 1, that little fraction button, A, B/C, to the 1/3. And then again, that should equals 2. Now, if that is not working when you type that in, please reach out to me and I will show you how to do it on your calculator. Okay, let's try the second one. So what if I do 125 to the 1/3 power? So again, I need 125. I need to know what times what times what is 125. Basically taking the cube root of 125. The answer to that is 5. Okay, so 5 times 5 times 5. Now I just need one of those factors, so I just need one of them. So the answer to this is 5. All right, let's try to use that same reasoning. What if I was doing 125 to the 2/3 power? So again, you take 125, and this bottom number tells you basically what root to do. So I'm doing the cube root. So again, I know 5 times 5 times 5 is 125, and I need to take 2 of those repeated factors. So if I take that one and that one, 5 times 5, that actually gives me 25. So my answer to 125 to the 2/3 power is 25. All right, using that same reasoning, I want to know, could you solve these 3 without using a calculator? Do you think you could figure them out? So I want you to pause the video, and I want you to try these 3. Okay, let's check them out to see if you did these right. So you need to basically take the cube root of 27, or if you split 27 up, it's 3 times 3 times 3. Okay, and then I need to take 2 of those repeated factors. So 3 times 3 is 9. So your answer to the first one should be 9. All right, 32 to the 3/5 power. Basically, you're taking the 5th root of 32. So I need to know what times what 5 times 1, 2, is equal to 32. Well, that's 2, I believe. 2 times 2 times 2 times 2 times 2 is 32. Now, I need 3 of those factors. 1, 2, 3. So 2 times 2 is 4, times 2 is 8. So the answer to that one is 8. Okay, and then the last one I'm going to do in blue down below. 25 to the 3/2. So basically, if I take 25 and I do 2 repeated factors, that would be 5 times 5. It says I need 3 of those, so I need that, and I need 1 more of them. So 5 times 5 times 5 is actually 125 for that third answer. So hopefully that is making a little bit of sense how that works. All right, so here's something that I would put in my notes. When you are working with any fractional exponent, so let's just say I have like 5 to the 2/3, or let's do 125 to the 2/3, sorry. The top number when you have a fractional exponent is always like how many factors of it you take, or I always like to say that's to the power, and I'll show you what that means in a second. And the bottom number is the root. Okay, now what we're going to work on next is I'm going to show you how to write these in several different ways. So if I give you something like this, instead of just coming up with the answer, there's a couple different ways to rewrite it. So I'm just going to start with this one. So again, if I was going to work this out, I would need to do 125, split it into 3, take the cube root of it, which ends up being 5. So 5 times 5 times 5. And then I need two factors of that. Okay, so 5 times 5, which is 25. So my answer to this problem is actually 25. Okay, now another way to actually write this problem right here in red, I'll show you another way to do it, is like this. Okay, basically I am taking 125 and I'm taking the cube root of it first, right? This number down here tells you the root. Okay, after I get that, I get 5 for an answer. I need 2 of those factors. I'm basically taking it to the second power. So one way you can write it is like this, with a little squared on the outside. Now, another way you can write the same thing is I can put the 3 here, and I can put 125, and I can actually put the squared inside there. So I want you guys to grab your calculator. I want you to do, if I was going to do this one, take 125, square it. Take the cube root of it, then you should end up with 25. Now on this one, you would do the cube root of 125 first, and then you would square it. You should still end up with 25. So these are both the same exact way to write this problem. Okay, now one other way that you can write this, I'm going to kind of show you. This is brand new, so it's tricky the first time you see it, is I could actually write 125, and I could start by just saying, okay, I'm going to take the cube root of it. Okay, so I'm going to say to the 1/3 power. That's a fractional exponent. And then once I get that, so there's the cube root of it, I'm going to, I'll just put parentheses around it, I'm going to square it. This actually equals the same thing as this red. Okay, because think, if you did a power to a power right here, a power to a power, if I multiply that, I end up with 2/3, which is what I had here. Okay, so I'm going to give you another example because that was kind of a lot. So let's say I give you this problem. Let's do 32 to the 3/5. Okay. So again, you could solve it. I want to know if we could rewrite this in at least 2 different ways. Okay, so the first way I could rewrite it is with a radical symbol. This is called a radical. And I know I am starting by doing the 5th root of 32. What times what times what times what times what is 32? Once I get that answer, I need to take 3 of those factors. You see that 3 up there? So I'm actually cubing this. This would be a second way to write it. Okay, now a third way to write it is you could, again, take the 5th root of 32, but you could put this 3 on the inside here. You would end up with the exact same answer. Okay, so you could actually cube the 32 first and then take the 5th root. You would get the same exact answer. Okay, the next way to rewrite the same thing is I could take 32, and I could start by just saying, oh, I just want to take the 5th root of it. See what I get. Ends up being 2. But then I need 3 of those factors, so I'm going to cube that. again, if you were to multiply that out, you would end up right back with 32 to the 3/5. So again, these are all different ways to write the exact same thing. One more way to write this same thing is I could actually do 32. Oops, don't have my pen. 32, I'll just grab a different color, black. I could cube it first, and then I could take the 5th root, so I could go like this. Again, still would give me the exact same answer. Okay, let's do a couple where we go the other way. Let's say I give you it written a little bit differently. Let's say I give it to you written like this or this. Can you rewrite it a different way? Okay, so here's what I kind of do when I do these. Okay, I know 3 is the base. Okay, I see my power is 4, and this symbol right here, if there's not a number in here, that's the square root. So I might write it like that. Now, if you guys look at that, 4 over 2, that's the same as 2. So it really could also turn into 3 squared. Now, another way to write that same thing is I could have wrote the square root of 3 to the 4, and then I could have the 4th power on the inside. Or one other way is I could say, okay, I'm doing the square root of 3. That's 3 to the half, and then to the 4th power. So those are all different ways to write that same one. Okay, let's look at the second one. Okay, so same thing. My base is 2. Okay, I'm going to write my fractional exponent. All right, my root is 3, and then my power is 5. So I could write 2 to the 5/3. Okay, I could write this the same exact way, except I could put the cube out, cubed here, the 2 here, and I could put the 5 on the outside. That would give me the same answer. Or I could do 2. I could say, well, I'm doing the cube root, that's to the 1/3 power, and then to the 5th. So those are a couple different ways to write those types of problems. And again, I could actually find the answer too, but this section was just on rewriting it. So now I'm going to have you guys try some. Hopefully you're not too confused. If you are, I will do a Google Meet tomorrow to help you with this a little bit more.